this is a Python code right now. The very first thing I want to start with, I actually want to, assume that, the intercept is random. Okay, or to use an intercept, random intercept model. Okay, because I told you the other time, we could have a random intercept model. We could have we could make the slope to be random. Uh, we can also have the combination of the two. Okay, like I said, we're actually going to import pandas. We're going to import stat models. We're going to import scipase.stats. We're going to import stat models formula dot API as SMF. Then, of course, this is data. Okay, so I'm actually going to copy that right now. Okay, give me 1 second. I'm going to copy that into. I'm going to copy all this into my Python. I'm going to start sharing my Python right now. Okay, give me 1 second. I'm actually going to share my Python right now. Okay, so this is my Python right now, Jupyter. Okay, so I'm going to click on Python 3. As you can see, that's Python 3. And after that, and I'm actually going to, paste that. Okay, this is what I want to. Maybe what I'm going to do. Let me do it one by one. Okay, so that you'll be able to understand. Okay, these are the packages. I'm going to run that. Then I'm going to go to the data right now. Okay, let me for show you the way the data is going to look like. I'm going to run that, and if I want to see what is in the data, then I'm actually going to run that now. And of course, you can see the data right now. Okay, this is an hierarchical data structure. Take a look at that. Okay, this is the ID of the rat. Okay, these are the weight of the rat. Of course, this is the gender of the rat, male or female, and this is a group that we talk about. Okay, group 1, group 2, I think up to 20 something. Okay, yeah, up to 27. And of course, we have the size of the rat in a particular group. Okay, 12, 12 and so on like that. And of course, it's going to be a combination of the control or our high. We have the control. Some rat was given placebo and some were given the high dose. Okay, now that is the data that I'm showing you right now. Okay, so the code to implement the model. Okay, the random effect, the random intercept model that I talk about. Okay, the random intercept model that I talk about. So I'm going to run that now. Now take a look at what I have. This is the result. As you can see right now, this is the result. And of course, this we got the intercept and the other, estimate. This is the coefficient, the standard error, and these are the p. You can see the p values associated with that. Of course, the intercept is significant. Of course, this is significant and so on like that. You can see that now. Okay, so this is how this is the output. Okay, as you can see right here. So this is trying to tell us the number of group is 27. The minimum group size, okay, is 2. The maximum is 18, and this is a main group size. Of course, we have the likelihood in case you have different kind of models that you actually want to compare. Of course, you can actually compare the likelihood, and of course, this actually converge. Okay, there's no any problem here. Okay, so I'm gonna go into another code. I'm gonna go into the material right now. Give me 1 second. I'm gonna go back into the material. Okay, so I'm showing the material right now. We've already implemented the random intercept model in Python. Now we want to go to another one. If you take a look at this random intercept model with or without interaction time. Okay, we want to look at that when there is no interaction time. Okay, so we have looked at that when there is interaction time. So if I try to copy that, and I'm actually I'm going to stop this share now because I'm actually going to share my my Python. Okay, so that's my Python. I'm actually going to copy it, paste that, and I'm actually going to run it. Okay, take a look at that. So this is what we have. when we don't talk about interaction. If you take a look at this, there's an interaction here. You can see treatment with the sex. You can see that now. Okay, so we have interaction right here, but there's no interaction right here. You can see that now. And of course, you can actually uh, compare, the likelihood here with the likelihood here to be able to say which one is better. Okay, am I going to consider the random intercept with interaction or without interaction? And that's exactly uh, what we have right now. Okay, can you see the output? Okay, so I'm gonna stop the share now. I'm actually gonna go back to the lecture material. Now, this is the lecture material right now. We just did the one without interaction. Now, the next thing we want to talk about, the random slope. Okay, random slope model. I mean, the random intercept and slopes are independent. So the random slope model. So I'm going to copy that right now. Okay, that is the code, and I'm actually going to copy that, and I'm going to paste that into my Python interface. Okay, so now this is my Python interface. I'm actually going to paste that now, and I'm actually going to run it. Okay, so this is what I have when I run it. You can see right now. So that is what I got. That is a result. Okay, like I said, you can compare the likelihood, okay, of different models. Okay, and this actually converge as well. Okay, now I'm going to stop this here now. I'm actually going to go back to the lecture material. Yeah, this is a lecture material right now. We're going to the next one. Okay, this is a random slope model. And in this random slope, the first one that I did, the random slope model here, assumption is that the random intercepts and slopes are independent. Okay, they don't have connection. Independent means they are not correlated. But what if in a situation whereby you are talking about random slope model and the random intercept and slope are correlated? So it's going to be this one here. Okay, where the random intercept and slopes are correlated. So I'm actually going to copy that right now. Okay, copy that right now, and I'm actually gonna share my Python interface. Okay, then I'm gonna paste that. Okay, then I'm gonna run it. I'm actually gonna run it. Okay, so this is what I got. You see that now? That's gonna be the output. Okay, you can see the Python output right now. Okay, so I'm actually gonna stop my share. I'm gonna go back to the lecture material to see what is next. Okay, so what is next? Of course, in conclusion, right now, of course, I've been able to introduce you to mixed regression model that we also call random effect model, that we also call hierarchical model, because it's called hierarchical model because it's actually applicable to hierarchical data structure. Okay, and that was why I said the dependent data structure go by many names: longitudinal, cluster, repeated measures, multi-levels. We also call it multi-levels, okay? So, and of course, we're trying to understand the multi-level nature of our data set. That is critical to any statistical analysis, okay? We need to be able to understand, when we understand that, of course, we'll be able to know, the appropriate statistical methodology that can actually be used. And I also want to tell you, ordinary least square regression approach is not appropriate, okay, to handle multi-level data structure, okay? So finally, a linear mixed model is one approach that can be used for the dependent data. Okay, so what we're going to do next time? What we're going to do next time is going to be mixed hierarchical model in generalized linear model, okay? Where we're going to talk about, mixed model, hierarchical model, random effect model, in logistic regression model, in Poisson regression model, and so on like that. So that's what we're going to do next. Yeah, I wanted to appreciate everyone who have attended my lecture today. Hope you guys enjoying uh, about enjoy my lecture. For those who are going to watch, that are going to be watching the video, if you have any comments, concern, you need clarification, of course, you can actually, uh, reach me through the email on the course canvas. Okay, so make sure you stay safe and you have a good day. Bye for now.